Today I will be discussing the raw data format of DC operating point. What is a DC operating point of SPICE simulation? Usually it's a DC solution of a circuit. This circuit consists of different components with its own current versus voltage characteristics. This circuit may consist of different components with its own current versus voltage characteristics. When we perform a DC operating point solution, the capacitor will be considered as open circuit and the inductor will be considered as short circuit. Why? The answer has been discussed in previous lectures. If we look at the impedance of a capacitor, Z sub C equals to 1 over SC. S variable goes to 0 at DC solution. The capacitor has infinite impedance, and it is like open circuit. For impedance of inductor Z sub L, when S variable goes to 0 at DC, it has 0 ohm impedance and is like short circuit. The DC operating point will give you a list of node voltage and loop current as the solution. In LTspice, you can go to Simulate, edit simulation command, and choose DC operating point. The syntax will be simply .op. A few more notes about DC operating point. It is about the static simulation when time t equals to 0. After the simulation, the operating points of the circuit will appear in a dialog box. Also, you can move your mouse to node or component to check the voltage, current, and power dissipation in the DC operating solution. In the lecture folder, there's a LTspice schematic file. Let's double-click open it. So this is a very simple example of a DC operating point. We have voltage source V1. Resistor R1 is in series with diode D1. So R1 and D1 are powered by V1. In this condition, if you right-click over V1, you can see the DC value is only 1 volt. Resistor R1 equals to 1K. If you right-click over the diode, you can see the model number is 1N5817. It is a 1 amp diode with breakdown voltage 20 volt. .op means DC operating point. If you run the simulation, the DC operating point results will pop up. You can see the voltage at Vin, because we have a net name in, is 1 volt. This net name is anode, this value as voltage. Also, the diode current, resistor current are shown here as device current. The last one is the current by convention into the V1 because the current actually is flowing out of V1. Sign is negative. In other words, a negative current flows into V1. Let's close the result window and LTspice. Go to the same folder, you will notice a raw data has been created. You can use Notepad in Windows to see the raw data. First part is header. Second part is binary data. The header file looks very similar as before, except the plot name becomes operating point. Flags are all real because they are real numbers. Number of variables is 5, and the number of points is just 1 at time equals to 0. Binary data is still unreadable. So here is the raw data format for DC operating point. The source value is 8 byte. For this case, it's Vin voltage, followed by different variables such as anode voltage, current over D1, resistor 1 current, and current into the voltage source V1. Each of the variable is in 4 byte. Now let me move on to a quick demo using Python scripting. Before using Spider, make sure you close the raw data in Notepad. Let's go to Spider. First, make sure you are in the correct directory. Let's open the given Python code. You can see that code is very simple. We import LTspice 3. We use LTspice3.simData to read the raw data. The raw data name is the same as we created here, because we are using Python to read this data. sd.variables gives the name of all variables. sd.values gives all the DC operating points. Save as DC_OP. Let's run the code. Go to Variable Explorer. You can see two variables are created. Name variable is a list of 5 elements, from vin all the way down to iv1. There's a list of NumPy arrays. Each element is a real number in the type of float 64. And that's all for this demo. This is the reference for this lecture. Stay tuned. See you soon.